All right, this is the Michelson interferometer stacked with a Young double slit. The Young double slit is modified to be a Young Inquisitor. The Michelson interferometer is modified such that this arm is vertically polarized, this arm is horizontally polarized. I have another camera down there so you can see the double slit interference pattern. There it is. And how that interference pattern changes as I interrupt each of these arms. So first I will interrupt, currently you're seeing the double slit interference pattern. Now if I interrupt this arm, this is the vertically polarized arm, so you're only seeing the horizontally polarized portion of the laser beam going through the Young Inquisitor double slit. Single slit pattern. If I remove it, double slit returns. If I block the horizontal arm, single slit pattern is all you see. If I remove it, the double slit interference pattern returns. And the last thing I'll do is I'll modify this knob here to bring the two arms out of alignment, and you'll see the double slit pattern disappear. That's the experiment.
I'm going to explain in schematics what we've just seen. So this segment of the laser's path, it is polarized linearly at 45 degrees to the horizontal. A 45-degree basis state of the wave function can be thought of also as a superposition of a horizontal basis state and a vertical basis state, which we will get to in a moment. So this 45 degrees polarization travels to the beam splitter, where half of the intensity of this laser goes to the left arm and half goes to the bottom arm. Now along the bottom arm, it then traverses a horizontally oriented linear polarizing filter that's just slightly off angle. This is a reflective linear polarizer, which means that it does not collapse the wave function. The wave function continues, and so the 45-degree polarized light which strikes it, the horizontal portion of that wave function is able to continue to propagate to the mirror and then is reflected back to the beam splitter again. Whereas on the other arm, the polarizing filter is vertically oriented, so the vertical portion of that 45-degree wave function is able to pass through this filter and strike the mirror and continue back towards the beam splitter. These two beams, the left one vertically polarized and the bottom one horizontally polarized, then recombine in the beam splitter and travel towards the double slit. However, when you recombine a vertically oriented wave function with a horizontally oriented wave function, you end up with a 45-degree oriented wave function, which then strikes the Young Inquisitor. At the Young Inquisitor, the laser light is linearly polarized at the 45-degree basis, which is a superposition of the horizontal and vertical bases. Therefore, the horizontal portion of this wave function will be able to pass through the upper slit, and the vertical portion of the wave function will be able to pass through the lower slit. And then, at the zero-order half-wave plate on the backside, the horizontal polarized portion of this wave function will be retarded into a vertical polarization basis. So then coming out the back of this Young Inquisitor, you will have light which has traversed two different slits, but all of the light will be in the vertical polarization basis. That allows it to cause an interference pattern at the detector, also known as the wall. Now I will explain what happens when I alternatively cover one arm and then the other of this Michelson interferometer. First, the laser light is linearly polarized in the 45-degree basis. It then travels towards the lower arm of the Michelson interferometer and interacts with a horizontal polarization filter. The horizontal portion of the wave function then strikes the mirror and returns to the beam splitter. Now, the other arm I have blocked, and so the vertically polarized portion of this wave function does not return to the beam splitter and recombine. Therefore, heading to the Young Inquisitor, only a horizontally oriented wave function is traveling. This horizontally oriented wave function can only pass through the upper slit in this depicted Young Inquisitor, cannot pass through the lower slit. Therefore, out the back end, you will only have light which has traversed a single slit, and so you will get a single slit interference pattern and no double slit interference pattern. Now, for the alternative, light polarized in the 45-degree basis strikes the beam splitter. A portion of that light travels to the vertical polarization filter and vertical light that is in the vertically polarized basis, then returns to the beam splitter. Now, towards the lower arm, I have blocked the path, and so no horizontal portion of the wave function returns to the beam splitter, therefore only vertically polarized light heads to the Young Inquisitor. The vertically polarized light can only traverse the lower slit in this double slit. Therefore, you end up with a single slit interference pattern as we see on the detector.